In this video, we're going to look at how to solve circular function inequalities. For those who don't know me, my name is Chris Iannazzoni. I've been tutoring for about 2 years now, and I make these videos so that VCE students can do the best they can in math methods. With that out of the way, let's get into it. Inequalities are a bit weird when it comes to circular functions. Instead of looking for specific solutions, we're looking for a full domain of solutions. We use the following process when it comes to solving these inequalities. As a quick warning, this is one of the more complicated scenarios for circular functions, so if you already struggle with the basics of circular functions, then this isn't the place to start. Check my earlier video to help with that. Otherwise, let's get into it. So, step one is going to be to just get our exact values expression. That's just a matter of subtracting 3.5 from both sides and then dividing both sides of the equation by negative 1.5. Just don't forget to swap the inequality because we divided by a negative number. From here, we apply a substitution to our circular function, which just means taking whatever's inside the brackets of your circular function and replacing it with a letter. I'm going to use u instead. You do this anytime the brackets aren't just x, or in this case, just t. From here, we need to rewrite our old t domain in terms of u to make sure that all the transformation factors that are affecting the t are now reflected in our new domain. And we do that by subbing in the lower and upper bound of our t domain into our u equation to convert those t values into u values. From here, we have a fairly tame looking statement, but we're not out of the woods yet. Next, we need to figure out the domain of solutions for which the inequality is true. And for this, we need to take a close look at our unit circle. If we're looking for where cos is greater than or equal to 0, it just means where on the unit circle are my x values greater than or equal to 0. The good news is that the unit circle works exactly the same as a typical xy axis, where all the x values will be positive on the right and negative on the left. The challenge now is figuring out how do I represent this as an actual solution in terms of x, and we do this by looking anti-clockwise around our unit circle. We can see that as soon as we get bigger than pi over 2, the x values stop being positive, they go to negative. But as soon as we cross the threshold of 3 pi over 2, they go back to being positive. What this means is we just give our domain in 2 separate intervals, separated by the union symbol. Just a quick reminder, we're going to use square brackets in our interval because our inequality was inclusive, greater than or equal to 0. But we aren't done yet. We use a substitution, which means now we have to get everything back in terms of t rather than in terms of u. We do that by replacing every u that we see with what it was previously in terms of t, and then rearranging to get t on its own. We do this for all of our values in the domain, and basically all that boils down to is just multiplying everything by 6 and dividing by pi. Okay, so there's also the possibility of larger domains. Here's how you handle it. The good news is that the first 2 steps here are irrelevant, so we can move right onto our unit circle. So, for sine to be greater than a half, we just need all of our y values to be greater than a half. It's probably easiest to draw a horizontal line at y equals a half to better represent what you're actually trying to solve. From here, we can see that within one cycle, our domain is going to be from pi over 6 to 5 pi over 6, non-inclusive because the greater than sign is non-inclusive. But we don't want just one cycle, we want 0 to 4 pi, which means 2 cycles. We treat this the same as any other circular function. We just add 2 pi to all of our previous solutions. That's going to give us a second interval of 13 pi over 6 and 17 pi over 6. And once again, we're just going to join those 2 intervals with our union symbol.
If you found this video helpful, then you should consider joining my free community. I host a Q&A call every week to personally help you through any of your specific questions, and you'll also get access to more resources like this, including written and recorded lecture content, as well as practice exams and SACs with detailed solutions. It's pretty cool, you should check it out. I'll see you there.